scientists have boldly declared that the discovery of a brand new planet is distinct from any others that have been found. Not only is the size and location of this newly discovered planet captivating, but it also emits a glow that seems out of place. NASA, which is known for its groundbreaking investigations, has discovered this. Could it be that this groundbreaking discovery suggests that we are getting closer to resolving mysteries that have the potential to fundamentally alter our understanding of the cosmos? Is it possible that there is a world other than Earth? We may soon discover the truth behind these extraordinary illuminations as we investigate NASA's astonishing findings. The Dawn probe was launched by NASA in 2007 with the intention of investigating some of the most intriguing objects in our solar neighborhood. Fitted with 3 ion thrusters, Dawn began a voyage that started with a 14-month examination of Vesta, the second largest rock in the belt. Dawn relayed detailed visuals and metrics, unveiling Vesta's intricate terrain and abundant geological legacy. Dawn moved on to what might be deemed the most exciting part of its mission, after completing its goals at Vesta, a thorough examination of the dwarf planet Ceres. Dawn was able to escape Vesta's gravitational hold thanks to its ion propulsion and move to Ceres, something that conventional fuel-driven systems were unable to accomplish. These thrusters provided a continuous push, allowing Dawn to traverse immense spans and attain a consistent orbit around Ceres. Spotted in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the most substantial object within the asteroid zone, situated between Mars and Jupiter. Prior to its reclassification in 2006, it was thought to be the smallest dwarf planet in our system for decades. Ceres is one of the most fascinating bodies in the asteroid belt due to its singular characteristics. It is the largest and heaviest body in the belt, with an approximate diameter of 950 kilometers. Experts impatiently anticipated the inaugural high-resolution visuals of this enigmatic realm, which displayed radiant patches dispersed across its facade, notably within a prominent crater called Oketor. These luminous areas instantly sparked immense curiosity within the scientific arena. Before the Dawn endeavor, our best glimpses of Ceres were fuzzy, lower-quality photos captured by the Hubble Space Telescope. There was minimal knowledge about this dwarf planet, and the opportunity to gain detailed visuals promised exhilarating revelations. Our understanding of how the solar system came to be, and the significance of water in the creation of planetary entities, was the goal of the Dawn mission. The highly shiny materials, possibly salts deposited from evaporated water, were thought to make up the gleaming regions on Ceres, which were also found on other space rocks. This hint led to the possibility of cryovolcanism on Ceres, an occurrence where eruptions release not molten lava, but liquid water or salty mixtures. There is still no clear answer to the question of what these baffling illuminations actually are, or what secrets they might reveal about Ceres. Are they hints of current geological activity, or do they point to something even more extraordinary? Ceres is distinct from other inhabitants of the asteroid belt due to its volume, weight, composition, and likelihood of containing water and frost. Ceres, in contrast to the usual stony asteroids, has a composition that is similar to that of a comet. This suggests that it may have important information about the beginning of the solar system. After 2 years of transit, the Dawn spacecraft finally neared Ceres in early 2015, marking a pivotal event in its mission. The vessel drew closer to Ceres as it prepared to transmit the first close-up images of the largest member of the belt, revealing a once obscure world. Initial snapshots of Ceres depicted a crater-marked surface, pointing to an extensive record of collisions. However, it was the brilliant spots among the dusky, rugged landscape that caught the eyes of researchers and space buffs alike. As the clarity of the photos improved, specialists formed various hypotheses about these spots. Were they ice patches bouncing sunlight, or did they embody something far stranger? Ideas spanned from mineral deposits to potential traces of cryovolcanic action. To everyone's surprise, closer analysis showed that the brightest region wasn't one solid mark, but rather a grouping of several separate luminous areas. The most widely accepted explanation was that these were salt deposits left over from water that had evaporated. This indicated that Ceres might possess, or previously possessed, some geological mechanisms that could raise water or brine to its surface, where it would quickly vanish into space, leaving reflective remnants. An updated picture of a lively, complex world was provided by these observations, which added to previous concepts of Ceres. The idea that subterranean water or briny chambers might lie beneath the crust poses captivating inquiries into the prospect of extraterrestrial life. Sirius is often called a frosty world with a porous, yet solid, exterior. Unlike many other asteroids, which are mainly made of stone and metal, Sirius is notable for its rare construction. Its top layer contains a mixture of water, frost, and mineral compounds like clays and carbonates, making it less dense than its rocky appears. This suggests that Sirius has a substantial water reserve. Its rugged terrain is spongy, with ice and other volatile substances ensnared beneath, making it more similar to a comet than a typical space rock. Experts theorize that Sirius possesses a defined internal structure, featuring a slushy outer layer and an ice-enriched core, which constitutes nearly half of its overall mass. This slushy mantle may consist of stone and salty water surrounding a central mass, possibly made of heavier material like silicate rock. The existence of vast ice deposits implies that Sirius may have had liquid water in the distant past, especially if its core was warmed by natural radioactive decay. The Sirius' inner makeup sets it apart from others in its genre and prompts fascinating inquiries regarding its potential for active geology and the role that water played in its evolution. The series of discoveries of ammonia-bearing clays also suggests that the dwarf planet started out in a colder part of the solar system before moving inward. Ammonia can lower the freezing mark of water, which might sustain briny fluids on the surface. These findings about the series' composition and past expand our insights not only into this intriguing celestial object, but also the bigger picture of icy body development across the solar system. Cryovolcanism is a compelling and comparatively rare natural occurrence, especially next to the fiery volcanism we know on Earth. Instead of molten rock, these so-called ice volcanoes spew liquids or gases like water, ammonia, or methane. In environments with extreme cold, such as those found on Sirius here, these substances can exist as fluids or vapors. Cryovolcanoes on Sirius here function by allowing briny water laced with dissolved minerals to escape to the surface. When exposed to the vacuum of outer space, the fluid swiftly sublimates, transforming directly from solid or liquid into gas, leaving behind glowing, shiny salt deposits. These are the bright spots that can be seen across the surface of Sirius here. The area known as Spot 5 in the R crater houses the most notable of these. Due to its frequent dawn, observed changes and high brightness, this zone has received a lot of attention. Water sublimation is thought to be the cause of these variations, which suggests that cryovolcanic activity may still be taking place, or may have stopped not long ago, on this world. Beyond Spot 5, Sirius has numerous bright regions, each with its own distinct characteristics. Cryovolcanism may be widespread because these are dispersed across the planet's surface, rather than confined to a single location. These bright markings challenge the idea that Sirius was a dead or dormant world by highlighting its animated and dynamic nature. A wide variety of landforms surfaced as dawn continued to collect high-detail images. The crust of Sirius is littered with impact craters, each narrating a chapter of the dwarf planet's story. Sirius's terrain is speckled with countless impact craters, each serving as a record of the dwarf planet's tumultuous history. Researchers can learn a lot about the forces that shaped not just Sirius but many other similar bodies throughout the solar system, from these indentations. Whether these scars were caused by asteroid impacts or other cosmic encounters, they highlight Sirius's role in the larger story of the formation of the solar system and contribute to its distinctive personality. Moreover, the discovery of ammonia-rich clays on Sirius provides yet another enthralling clue about its origin. Ammonia is known to depress water's freezing point, which may have enabled liquid water to persist on or near the surface, either in the past or possibly even today. This supports the idea that Sirius may have originated in the solar system's chillier outskirts before shifting inward toward its present orbit. This migratory past could account for many of the peculiar features noted on its surface, such as ammonia traces and signs of icy volcanic activity. As experts persist in examining both the surface and the internal structure of Sirius, their findings continue to reshape our views on how planets take form, the likelihood of life in space, and the internal mechanisms that power geological activity in remote corners of the solar system. Sirius, once dismissed as a mere cold and minor asteroid, has emerged as a mesmerizing celestial body that defies traditional expectations and prompts us to reconsider what might be possible on far-off worlds. Through its years of dedicated surveillance, the Dawn spacecraft has helped reveal these new details about Sirius, mission, which produced the sharpest images and most precise data ever collected of this dwarf planet, remains a vital piece of our journey to better comprehend the solar system. Each photograph sent back from dawn revealed further secrets of this dynamic world, painting a portrait of a constantly changing landscape. These revelations mark just the beginning of what is expected to be a continuous inquiry into the mysteries of our solar system's outer regions. The scientific community will, undoubtedly dig deeper into the wealth of information gathered by dawn in the years to come, looking for additional clues regarding the possibility of life on Sirius and other similar bodies orbiting the Sun. As innovation advances and new exploratory missions are launched, even more astonishing findings are bound to surface. Will we discover additional evidence of liquid water beneath Sirius's crust, or new hints of icy volcanism? Time alone will reveal the answers. However, one truth, stands clear. The saga of Sirius is far from reaching its conclusion. As NASA exploration of Sirius progresses, the global scientific community remains captivated by the multitude of breakthroughs emerging. This tiny world's intricate internal design is one of its most compelling features. Its discovery could shed light on the origins of similar planetary objects throughout the solar system. Researchers are particularly focused on investigating Sirius's unusual surface formations, which, imply that it might still be undergoing transformation despite having existed for billions of years. The planet's landscape is fundamentally shaped by the presence of water in various physical states, which is a key driver of this ongoing evolution. The discovery of briny ice and convincing evidence of cryovolcanism open up new perspectives on the geological activity that takes place beneath the dwarf planet's crust. Researchers are looking into how icy materials might move beneath the surface, which could cause movements that lead to new surface formations. Additionally, learning more about how similar moons and planetary bodies in the outer reaches of the solar system behave and change over time could be gained by comprehending the role that salts play in this dynamic. The exploration of Sirius also opens up exciting opportunities to comprehend the wider phenomena shaping icy celestial bodies. Unlike their rocky counterparts, these frozen entities often display dramatically different properties. By analyzing how geological activity has altered Sirius's exterior, experts can draw comparisons and enhance our understanding of the developmental pathways of other distant moons and dwarf planets. Sirius acts as a live case study of these processes, offering priceless lessons in the science of planetary evolution. As the mission advances, fresh data from the Dawn probe is anticipated to uncover even more insights into Sirius's formation, internal makeup, and geological progression. The understanding of Sirius itself, as well as the elemental dynamics that have an impact on the entire solar system, grows with each new image and analytical result. These insights may well redefine how we interpret the early years of our solar system and broaden our sense of what is possible when it comes to locating life far from Earth.